Assalamu alaikum everyone. So I will do one example related to the Bode plot, something similar which is in your homework. So it will do some points clarified if you have any concern. So the example which I pick is something similar to if you have in your homework. So we have something h of s which is given to us 5 into 10 to the power 4 s divided by s square plus 505s plus 2500. So this basically a problem which is provided to you. So what we need to do first, this is not in the standard form. We need to bring this into the standard form. What is meant by standard form? That we all need to be a bit aware of. So when you remember, we used to write h of s something like this form, 1 over j omega divided by omega z divided by 1 plus j omega by omega p1. Since we know s square, two poles are involved, so we can write this expression omega p to this second part. Right. So if we have this form, this is known as a standard form. So first thing, whenever we have a problem, we need to convert into the standard form. So how we can convert this given HFS into the standard form? By taking something common. So let's write this currently as 5000. Let's don't change this thing. How can we represent s square plus 500, 5s plus 2, 2500 into the sum product of two poles? So we all know we can use directly the calculator, or you can write, if you remember your elementary mathematics, you can write 500s plus 5s plus 2500. Okay, and you do this thing, you do 5000s as it is. So if we take common from the first, it would be s plus 500 plus 5 common s plus 500. This means we can write this thing as 5000s divided by s plus 500 multiplied by s plus 5. Okay, this is what we normally use to write all the time or mathematics. But this is again not in the standard form. We need to bring in the standard form. What the standard form says, that we need to write denominator as something as 1 plus s divided by something. So 1 will make, if I divide this first by 500, it will become 1 plus this thing. 500 will be common from, same thing. But we will take common from the other second expression, 5. So it will be 1 plus s by 5. What will be result into it? 5000 will be divided by 500. Sorry, 505. So we will be left with some factor. That's one mistake. So it's not. It's 5000, so it will be 50,000. Sorry, if there are 4 zeros involved. Yeah, so there is a mistake. So now what will be left with it? 550,000 divided by 2500. So we'll be left with 20. And 20 what? 20s. So we will be like this thing. 1 plus s by 5 times 1 plus s by 500. Now is it in the standard form? Yes, it is in the standard form now. And what is the information we are getting from this expression when we write? We got this value that our 0, because this one, the which I'm pointing with the blue, is telling us zero's location, and this one is telling us pole's location. So interestingly, we have a 0 at origin, right? Because you just equate it to 0 and you figure it out. So if you put 20 s is equal to 0, you get s is equal to 0. So your 0 is at origin and your poles are at this point. S is equal to -5, first pole, or omega p1 is at this point, and omega p2 is equal to at -500. So two poles we know, and we know our 0 is at 0 point. But this is the standard form which we use for the Bode plot. Okay, so now let's go to the Bode plot and try to plot this equation, both magnitude and phase response. So what we can do basically for the magnitude response, I will write the expression on the extreme right. So we just again know what the expression was. 20s divided by 1 plus s by 500 times 1 plus s by 5. Okay, so that is h of s for us. Now, whenever we do the Bode plot, we go one by one. The first thing is that we need to only take the 0. So I will use different color codes. So the blue one I'm doing for this first 0. Okay. The green one I'm going to take this for the first pole, which is at 5. And the yellow one I'm using for this. Okay. So this is the color code I just mentioned. I'm going to use this thing. So let me start drawing this one on the scale. So let's draw this overall magnitude. Okay. And here we have something omega. Here is a magnitude, so I can write h omega mod. Now the interesting thing which we need to observe in this expression is this. First, we need to start with the 0, which is 20s. So we don't know the starting point. Since s is equal to 0, we don't know what is the magnitude at that point. But we know at a very much low frequency, it's a 0. This means it's going to be on the rise. Okay, so a positive slope is going to be. So we positive slope with a 20 dB per decade. But interestingly, we don't know the initial or starting value. But we have one information for the 0, that at s is equal to 1, we know the magnitude value. Just if we only consider 0 initially, as I'm saying, we're going to see 1 by 1. If I put at s is equal to 1, it will be 20. It's 20 numeric. If I want to talk in the log value, it will be 20 log 20. This will be approximately equal to 26 dB. Okay. So I know the value of a 0 at s is equal to 1. So or omega is equal to 1. So let's point the values of omega on this plot. So for example, I say this point as omega at 10 raised to power 0, this point at 10 raised to power 1. So per decade we draw 10 raised to power 3 and 10 raised to power 4. And similarly, this point is 10 raised to power -1 and this 10 raised to power -2. We don't know what's happening at s is equal to 0, but we know that it started at some point and it has a positive ramp. So what is that positive ramp doing? It is bringing at s is equal to 1 or omega is equal to 1. What is the omega is equal to 1? This is 0. So as omega is equal to 1, it will be from this point where I'm just drawing mine. Okay, so this is the point. So at this point, the magnitude is, if I just mark here, again, I'm marking here a 20 dB and I'm marking here a 40 dB. I'm marking here 60 dB and 80 dB. And similarly, this is 0, this is minus 20, this is minus 40 dB, and this is minus 60 dB, for example. I'm just like putting some numbers. So what I got to know, at s is equal to omega is equal to 1, this value is somewhere here. Okay, and I don't know what was happening before, but I know till this point I have something like dotted here, but it's going like this with a slope of 20 dB per decade. So what will be at, let's say if it has 1, omega is equal to 1, it is 26 dB. At omega is equal to 11, it will be 46 dB. This is going to be that I'm just writing the numbers 26 just for your own understanding. 46 dB, and this will continue with a what slope? 20 dB per decade. So whenever you have a 0 at origin, you can at least identify its value at s is equal to 1, and then you can just go back and front per decade. So what we got to know at this one, and similarly we got to know at 1 decade before, the value is also going to be 6 dB. So we get to know all this information from this plot. Might be this blue line is again not totally 100 to the scale, but at 1 decade back it should be 6 dB, at then follow up, so it should be like this. So that's why we can just do this asymptote sort of stuff. That trend is like this. We don't have to exact, but this is enough information for us, and it can go like this. Now, what about the other pole? Let's go with the green one with a pole at location 5. We all know that 5, this will be 1 somehow, this will be 10. So 5 will be somehow near to this point. So let me just again point this point. At this point, what we are saying, it's going to have a 0 dB, and at the end I will add all of them together because they are going to be superposition. At this point, because of the Bode approximation, it's going to have a 0 dB, and then since it's a pole, it's going to have a minus 20 dB per decade. So from onward, it will have, again, it might not be up to the scale, so you don't have to much verify my y-axis, but that's why I'm just writing. It's going to be minus 20 dB per decade. Okay. So that's going to be like this at s is equal to 5. And what about the yellow one? It's going to be remain 0 dB till what point? Till s is equal to 500. Where is the 500 point? This is 100, 1,000, 500, something like this. So till this point, it's going to be like this, and then it will shoot down with a negative slope, having minus 20 dB per decade. So combined plot kya hoga? Combination of all these three things, poles and zeros. You remember we add the pole and zero magnitude and the phases correspondingly. So अब इसमें हम क्या करेंगे? I will draw with the help of a black color what will be my net resultant. So my net resultant will be something like this. So I will start with the same point. Initially at 0 में add करेंगे the same response आएगा. It will be follow upping on this black line until we reach the frequency 5. So S यहाँ तक चलता रहेगा until we reach this point. At this point, my omega is equal to it's 5. So when my omega is equal to 5 radians per second, what's going to happen? Minus a plus 20 will be cancelled out by minus 20 dB per decade, and I will have a constant line. Till when this constant line will continue? This line will continue till the point when the next pole is going to arrive. So next pole kahan aa raha hai? S is equal to 500. Okay, 500 kahan tak hai? Yahan tak. Right? Till this point, I will have a 0 dB per decade. And जैसे ये 500 point पे आएगा, it will have again a, जिस तरह मैं कह रहा हूँ, might be not again up to the scale. You can use a ruler to draw correctly. So this is going to be minus 20 dB per decade. क्योंकि net एक 0 और एक पोल कैंसिल हो चुके हैं, एक पोल का इफेक्ट होगा. Let me draw this line a little because it's not looks up to the यहाँ से, and then it's going to go like this. ठीक है, a little better now. तो ये -20 dB per decade. तो यहाँ क्या था, 0 dB per decade. ठीक है, you all can say pole was 0 was cancelled by the pole. यहाँ क्या था, +20 dB per decade. The black line is the overall net magnitude response of this H of S. Okay. Similarly, we can do the phase response. So how we can do the phase response? I will do it here and using the same all colors which I just used here. Okay. So let's do this thing. Okay. If you do this with the ruler, it's more easy and you don't have any issue which I am having of drawing properly. So now again omega, I have now phase. So phase again I will draw individually and then we'll draw with the black color combined. So first of all start with the 0. 0 का normally phase क्या होता है? We know it's going to be plus positive. At that, if we have 1 0, by the end of the time it should be 90 degree. अब हो क्या रहा है? 0 is at origin. So this, since 0 is at origin, we don't know how many 0.0001. So this means at from the point 10 raised to power -2, 0 will be a phase of positive 90 degree. Let me now draw the values. So this is going to be 90 degree, 45 degree, 0, -45, and -90 degree. Okay. So at the start, because of this, let me also write the numbers here. 10 raised to -10, -1, 10 raised to power 0, 10 raised to power 1, 10 raised to power 2, 10 raised to power 3, and 10 raised to power 4. Now, because of this 0 at origin, I am going to have from the start of the value 0.001, 10 raised to -2 omega. When omega is 10 raised to -2, I'm going to, my angle will be 90 degree, meaning maximum 0 phase has achieved, and that's going to be plus 90 degree. So I will have this value till somewhere, till some number. What is that number? That value will be, it will be having a 90 degree till 10th time of omega p1 by 10. Omega p1 क्या है? 5. So 5 by 10, meaning till 0.5 hertz, I will have plane 90 degree. 0.5 hertz कहाँ तक होगा? Somehow ये 1 है, ये 0.1 है, तो it will be somehow like this. Log scale है, तो somehow till here. So till here I will have a plane line 90 degree. ठीक है? At point till 0.5 hertz. So I will draw this blue line. Let me again. मैं जो 0 का effect मैंने draw कर लिया. 0 का effect is again just sorry for this thing. I just want to have a 0 effect first. So 0 का effect just 90 degree. Okay, nothing. So already we have achieved saturation. So 90 degree आपके पास plane angle आ जाएगा. Now let me draw the effect of a pole only. So then we will have a black line like a magnitude. जिस तरह हम लोगों ने पहले magnitude रखे. So this is only I'm drawing the phasor, but individually first. So for 1 plus s by 5, क्या होगा? We are going to have an angle of 0 degree until I reach the 1 by 10th of the omega p1, which is 5. So I will have a 0 degree, which is marked as a green, till some point, 0.5. उसके बाद क्या होगा? It will start ramping down with the -45 degree per decade until it reach 5 hertz. So यहाँ से लेके 5 hertz कहाँ है? Let me mark 5 hertz. This is 5 hertz, for example. And also I need to mark the 50 hertz point because जहाँ तक उसने maximum approach करना, this is 100, so this is 50. So I can just easily do this thing. So it will go till this point. यहाँ से ये -45 hertz है. And then it will go till -95. Okay, and then it will stay here. So this is because of 1 plus s by 5. So इसको मैं क्या कह सकता हूँ? Here it is -45 degree per decade. ठीक है? Blue line is 90 degree, green line is starting with a 0 degree till reach 0.5 hertz, because this is omega p by 10, ramping down with the -45 degree per decade until it reached 10 times of omega p1, meaning 50 hertz, so 50 radians per second, and then stays at the angle of -90 degree. This is alone response of omega p1, 1 plus s by 5. Now let's do the plot of 1 plus s by 500. So what will happen? Again, let's mark the point 50 again, because until omega p by 10, it will remain as 0. And till where? Till 5,000, 10 times of this. This is 1,000 and this is 5,000 will be somehow, I guess, here. Yep. So we have a yellow line which will be 0 degree until we reach 50. So 50 पे आने के बाद क्या करेगा? It will ramp down to the point here minus this one. ठीक है? अब यहाँ से क्या हो जाएगा? -45 degree per decade. अब क्या करना है? We need to add all three of them together so that we can get net result. Means you can directly do that thing. I'm just doing for your own understanding. I feel more sometimes for simple scenarios like this one, you can do directly. Otherwise, just combining makes life more difficult. But this is the way normally we do. So what will happen? We will follow this line. Yeah, we'll follow this line for till which point? Till 0.5 hertz. From 0.5 hertz tak we will have a 90 degree. After that, it will start going down until we reach the point. हम 0 level पे कब तक आएंगे? Until we reach 50. So जैसे 50 radians per second पे आएंगे, we'll reach the point which is ये. क्यों इस तरह हमारे पास आ रहे हैं? Why we are going down like this thing? Because हमारे पास initially phase है 90. That phase is now going to be nullified with the help of first pole, which occurred, and with a -45 degree per decade. So till 50 hertz we go like this. After that क्या होगा? Now at 50 radians per second, we start getting the effect of second pole. So we will continue on this line. Okay, we'll continue on this line until we reach 10 times of omega p2, which is this one. So we'll continue on this line, -45 degree per decade. So this black line is the phase response. So this black is the phase response of this overall function h of s, and here black is a magnitude response. And that's what the way you have to do problem 3 and 4 of your homework 5. 4, you just have to also bring a feedback in it, but third is just doing 2 Bode plots, which you have to normalize first, and then you have to represent them accordingly. Okay, so that's what you just need to do. So I just recorded a small video so that you can get an idea about that thing. Right. Thank you for your attendance.